Welcome back, students. We have already learned linear search in previous class. Today we will learn binary search in array. Binary search works only for sorted array. It may be sorted by ascending order or descending order. In this type of search, search value is compared with middle element of array. If the value matches with the middle element, then search gets completed. If the match is not found at the middle element, again it will search with middle element of first half, otherwise second half. It depends on the searching value or sorting of the array. For example, if the value being searched is lesser than the middle element, then it gets performed only in the first half. This is in the ascending order array. If the value being searched is greater, then it will perform in the second half of the array. This process will keep on repeating until the element is found or until search get completed. If element is not found, then search will get completed when first index number is equal to the last index number. We will understand this by few examples. Later, once again we will come to this and then we will read. So I have array, integer array having the values like this. Let us search for element 23. So for your reference, I have given index numbers, starts from 0 and the last index number here is 11. Now it should find the middle index number and then for that whichever element is there, it will compare with that element. How the middle element is found is like mathematics. We will take the first index and the last index. We add both and divide by 2. Automatically we will get the mean. So that is the middle index we will get. For your better understanding, I have matched first index, last index, even the middle index with the colors. Please follow the colors also so that it will be easy for you to understand. For the first time, the search will be in the whole array. So it takes the first index as 0, last index as 11 here, and then we will add first index and last index divided by 2. So we will be getting 5.5. Index number cannot be 5.5, so we leave the decimal part and then take only the integer part. Here in the program also, it will do automatically implicit conversion, that is integer divided by integer, it gives only the integer value as quotient. Now in the middle element 37 is there. So we are searching for 23. It is lesser than 37. So when it is sorted array, there is no meaning in searching this second half, because what we are searching will be in the first half only, because search element is lesser than the middle element. So it will not search in the second half. Now the middle element is already compared. So remaining segment, that is index from 0 to 4 only we have to search. So here first index remains as 0 itself, but the last index instead of 11 it should be 4. We already found middle element as 5. So what we do, middle element minus 1 will give the next last index. So in round 2 we will have first index as 0, last index as 4. So 0 plus 4 divided by 2, we will get 2 as the result. So in 2, 23 is available, which is equal to which we are searching. So what happens? Search becomes successful and then it will print the index number of that element. Let us see next example. I have a new array here after removing the last element of that previous array. So let us search for element 51. I have the index number from 1 to 10. So at round 1, the first index number will be 0 and the last index number will be 10. So middle element we find 0 plus 10 divided by 2, we get exact 5. At index number 5, I have 37. So 51 is greater than 37. So no meaning in the searching first half. So automatically it will search in the second half. First index of the new segment is arrived by adding 1 with the middle element. So it becomes 6. Last index remains unchanged. So now we get 6 plus 10 divided by 2, that is 16 divided by 2, we get 8 as middle element of this segment. At index 8, 54 is available. 51 is lesser than 54. So it is not necessary to search the second half again. Now the first index remains same. The last index will be middle index minus 1, that is 8 minus 1. So now for round 3, the new value of middle index will be 6 plus 7 divided by 2, that is 6.5. Here again we will take only the integer part, that is 6 as index. So at index 6, 45 is available. So 51 is greater than 45. First half we don't need to search. To get the first index, we add middle index plus 1, we get 7. And the last index is also 7. See, now first index is also 7, last index is also 7. If the element is not found at this index, then search also will stop. Let us check. 7 plus 7 divided by 2 will be 7 itself. So we get 51 here. 51 which is we are looking for. It becomes successful. If some other element is at that place, and then it becomes unsuccessful, as first element and last element both are same index. Let us go to one more example. Index number of this array is 0 to 11. So let me search for element 11. At round 1, first index is 0 and last index is 11. So we will have middle element as 0 plus 11 by 2 as 5.5. Only integer part of this we will take. So we will take 5. At 5, 33 is the value available. 11 is lesser than 33. So greater than the middle element index numbers, we don't need to search. The first index of new segment of array will be 0. The last index will be middle index minus 1, that is 4. So at round 2, 0 plus 4 divided by 2 is equal to 2. Element at index number 2 is 23, which is again lesser than 11. So the first half will be searched, second half we don't need to search. First index remains the same, last index is middle index minus 1. So that becomes 1. So at round 3, 0 plus 1 divided by 2, it will be 0.5. So we take only 0. At 0, 11 is available, which is equal to the element which we are searching for. So search becomes successful. I will give you the last example where the search element is not available. So example 4. I am searching for 53, which is not available in this array. So here the first index is 0, last index is 10. So we get 5 as answer. At 5 we have 37. 53 is greater than 37. So it will not search in the first half. First element becomes middle element plus 1. Last index remains same. Now at round 2, 6 plus 10 by 2, it becomes 8 again. At index 8, 54 is available. 53 is lesser than 54. So the second half will not get searched. Now the first index remains same. Last index is middle index minus 1. So that is 7. So at round 3, 6 plus 7 divided by 2, it is 6.5. So it will take only integer, that is 6. At 6, 45 is available. 45 is lesser than 53. So we don't need to search in the first half. So index number of first element will be middle index plus 1, that is 6 plus 1 is equal to 7. And the last index also 7. So at round 4, 7 plus 7 divided by 2 is equal to 7. So at index 7, 51 is available. Again, which is not correct, being first index and last index are same, search stops. Then it becomes unsuccessful. Students, when we do manually, we will do like this, but when we do a program, all this round 1, round 2, round 3, round 4, all will be done in the loop. So it will be very easy to write the program. Just we need to understand how we change the first index and last index and which segment to be searched. Let us do a program. As usual, I will copy codes from the previous program until we take the input. I will create a new class called binary search. I change the name of the class. Here we need 3 variables. Instead of this, we will have first index 0 as default, and then last index in the beginning it will be 1 lesser than the length of array, that is arr dot length minus 1, and also we need middle index, that is m. Here we take the input. After taking the input, user will also give the element to be searched. So for that, then I assign the value int s is equal to integer dot parse int of br dot read line of. Now we need a loop to perform, but we don't know the exact number of iterations it is going to happen. So we cannot use for loop. Instead of that, we will use while loop. What condition here we can give? The first index always will be lesser than last index, and it will search until first index becomes last index, that is both index becomes same. So we will give the condition here, first index is lesser than or equal to last index. First we need to find the middle index. So middle index is equal to first index plus last index divided by 2. Do not forget to put this first index plus last index inside the bracket, otherwise it will give other meaning, that is L divided by 2, and then it will add with the first index. Then it will not work. After finding the middle element, we will compare element of that index. For that we will give if condition. If, so which we are searching is s equal to arr of that middle index m. So if this is true, we can print the index number where it is available. So system dot out dot print line of element is available at index, that is m is the index, so m we will print. And then we should have a boolean type variable, so we have not given that, we will give here boolean flag is equal to false as default value. So now it will become true, flag is equal to true, and then we can break the loop. Else if condition, if search is greater than arr of m, then what we do, we will not search in the first part of that array. So first index will become f is equal to middle index plus 1, else automatically it will be s will be lesser than arr of m. So now what we do, last index will be middle index minus 1. So this will keep on repeating until f is equal to L. So if it is false, then it comes out of the loop. Now we can print if flag is equal to false. Otherwise this we can also write flag is not equal to false. So not we can write here. Then we will print system dot out dot println of element not found. So now we will close the method, close the class. Let us compile. No syntax error. We will run this. I will give 1, 6, 9, 23. It should be sorted. So we should give the greater value only. 67, 86, 90, 112, 156, 178. So which we are looking for, maybe 6. So element is available at index 1. Let us run once again. 1, 5, 9, 23, 56, 478, 598, 634, 700, 841. So let us search for 841. So element is available at index 9. So that is one lesser than the length, last index. So in case it is in descending order, how we can do it? Instead of s is greater than arr of m, we will just change into lesser than arr of m. So automatically the whole process reverses. Let us check. No syntax error. I give 987, 876, 654, 543, 432, 210, 112, 110, 108, 95. So let us search for 432. So it is at index 4, 0, 1, 2, 3, 4. Let us run once again. Ten, 9, 8, 7, 5, 3, 1, minus 10, minus 12, minus 15. So let me check minus 12. It is available at index 8. So students, it is clear. Now let us learn how to search in string type of array. So I will change the array type. So let me change this as 6. And then when we take the input, we will have only br.readline of, and then even this will be string type. And then taking the input will be br.readline of. Here in the condition, instead of equal to, we will use dot compare to, which gives the integer type output, checks lexicographically. String functions I have already explained in the previous lessons. You can check there. S dot compare to, then this will be inside the bracket, which is equal to 0. Here again we will have the same thing when it is greater than 0. Greater than 0 is for ascending order of that array. That is, ASCII value of first letter of the string which we are comparing is greater than the middle element. So we will get the positive value which is greater than 0. So at that time we will not compare the first half of the array. So it becomes first index will be middle index plus 1. In case it is descending order array, then we will change the symbol to lesser than 0. Let us compile this. Let me give Anant, Balu, Chetan, Dhanabal, Ishwar, Joshua. So we will search for Ishwar. It is available at index 4. So 0, 1, 2, 3 and 4. 5 is the last index. In case it is in descending order, we change this into lesser than symbol. Compile. I give Windows, Unix, Office, Microsoft, Excel, DOS. Let me check for Unix. So element is available at index 1. Here we had given 10 elements. It remained, we didn't change at all. So it was 6, right? We can give 6. I should give in the descending order. So let me give HP, Logitech, Lenovo, Epson, Dell, Acer. Let me check for Dell. So element is available at index 4. It is right. Students, let us revise the points once again. I hope it is very clear for you. Please keep on watching my videos and learn more. Thank you, students.